Hello, my name is Eun-Cheol from Yonsei University. I'm going to talk about my paper on virtual underwater experience by using visual motion delay effect. First, please see this video. Does it look natural? Maybe it is too fast for underwater resistance situation. If we are underwater, moving our body is much more uncomfortable than in air. It is because fluid dragging, in other words, water resistance, much bigger density of water makes bigger drag than air. Through our lifetime, we know this water resistance, and we can perceive this motion is not suitable for underwater situation. This is because the real user is in air, so the motion is not suitable for underwater. This inconsistency of motion make users disturb users' immersion. There are several researches to reduce this inconsistency. In this work, they made additional dedicated hardware to imitate swimming pose, and others make waterproof HMD and made users to swim in real pool. But these settings are very challenging to general users who want to play various VR content in their own room. Our goal is to visually convert the motion without any additional hardware, and we call it as virtual visual motion delay effect. And our goal is to make motion looks proper to underwater scene. And finally, we test it can provide better immersion, enjoyment, and presence in the underwater VR experience. Our proposed method consists of two components, drag force and recover force. Drag force is to simulate the physical fluid drag force of water, but it alone, there should be this mismatch of positions. So we use recover force. It is artificial force to gradually synchronize the real hand's position and the delayed avatar's position. First, we can get velocity and acceleration of users' tracked motion with this way. We derive velocity from positions, and we can derive acceleration from velocity. And now we calculate drag force. It simulates the physical fluid drag force. We use physical equation for fluid dragging. We convert this force to acceleration by dividing m. We summarize all constants into one constant c hat. Now we can get acceleration for dragging. Next, we calculate recover force. Recover force can be implemented various methods, and we tried several implementations and found that a form of elastic force produces realistic results. We convert force to acceleration by dividing m. We summarize all constants into one constant c hat. Then we can get acceleration for recovering. Finally, we summarize all the acceleration we get. With this, we can derive new velocity and new position of hand. We apply this method to hand motions and HMD motion. Forces are applied considering the directions. An application to HMD is only forward direction because the others cause high risk of cyber sickness. This is illustration of our proposed method. The faster hand is actual user's movement, and the following hand is our applied motion. Our method is applied to slow motion. We made underwater scene like this. We tried to make it realistic to users feel more like being in water. In this scene, we conduct 2 experiments. The first one is to test on hand motion, and the second one is for HMD motion. Experiment 1 is to test effect on hand motion. The cases is just not delayed motion and delayed motion. Task is just to spend 3 minutes in underwater. There are bubbles which users can interact by touching, but we did not give additional task to do because we wanted them to not concentrate on specific mission, but just watch their movement and the underwater scene. We use questionnaires E2I to test immersion and enjoyment, and PQ test for presence. We also made custom water-related questionnaire, which consists of 3 questions. My hand motion felt like being in water. My walking motion felt like being in water. I felt like I was in water. This is the result. In presence, immersion, and enjoyment, our method increased statistically significant improvement, and also significant increase in water-related questionnaire. And experiment 2 is for HMD movement. The case is same, not delayed motion and delayed motion. Unlike to test the experiment 1, we give specific task. The users have to follow moving target. It is because we have to we have to test on HMD movement. The task took around 2 minutes. The others are same, but we used one more questionnaire SSQ because we manipulate HMD tracking, so it can cause cyber sickness. And this is the result. There was no statistically significant difference between 2 cases in impression, presence, immersion, and enjoyment. But in water-related questionnaire, there was significantly increased. This graph shows the result of SSQ. SSQ score shows the cyber sickness effect in this experiment was trivial. We proposed drag and recover force to visually convert to more realistic motion in underwater VR. And we confirmed that our method can provide better experience in terms of immersion, enjoyment, and presence in hand motion. We also confirmed our method provide better water-like feeling by the custom water-related questionnaire. Thanks for attention.
Okay, are there any questions? Okay, so one from my side. Is it not the case that this method is just adding latency between move your hand and let it show up in your virtual environment? So because of this you don't see any problems with this? So it seems like that your study is not really showing that, but I'm very...
We have to consider the velocity because the driving force is velocity. First depend on scale of velocity. Driving force is depend on scale of the velocity. So just dragging the latency can make realistic motion.
Do you think to compare this also to some kind of passive or active feedback, haptic feedback approaches, so that you compare this with something that is really generating a certain kind of haptic feedback? So my question is simply whether you plan to compare your approach, which is only in the visual stimuli, to methods which are also using haptic feedback, so that you really slow down your hand or your arms?
The haptic feedback with our method can make better result, you think? So yeah, it can be a combination, I think. Then the result could be better, much better.
Okay, so any further questions? So then let's thanks the speaker again. So before you're heading off, I was asked to